let me build on that.
Yeah.
I think national security, there are two dimensions of national security. And I differentiate small case and large case. Small case, national security, small n, small s. I think that's, aircraft carriers and bombers and divisions and training programs. Capital national security, NS, is the dynamism of your economy, the productivity of your industry, the creativity of your ideas industry, the sense of fairness in your judicial system. You are here, you benefit from that larger case, but you're building that larger national security industry. Tell us how you think about your role on national security.
Number one, NVIDIA was birthed in the United States. We are a proud American company. We're inventive, we're vibrant, we're at the center of the single most important industrial revolution in human history. This is an industrial revolution in every single way as important as electricity. We are going to impact every single industry, every single company. Every country will build it. Every company will use it. We export American technology wherever the United States would like us to export the American technology. This is an extraordinary opportunity for us to make a substantial contribution to our national security. We also know that national security and economic security and economic prosperity go hand in hand. The wealthier our nation, the more we can fund the mightiest military on the planet. And I do believe that it is the case where, because of this new industrial revolution that we've started, we are creating new factories in America. We're creating new jobs in America. And somebody recently told me that we contributed more to economic growth singularly than just about any company in the world today to the American economy. And I believe that that's probably true. And the reason for that is NVIDIA is a multi-$100 billion company supporting multi-$100 billion companies going after trillion dollars of industry. And so the economic prosperity, the technology leadership, unquestionable. The economic prosperity that we can contribute to, unquestionable. Now the question then becomes, how do we think through the diffusion of, the export of, the proliferation of American technologies and standards? We should, of course, number one, safeguard our national security, the little n, little s, to ensure that adversaries don't have access to sensitive technology or advanced technology that we don't need them to have access to. We should, number two, ensure that American companies, American technology companies, through partnership with us, have the benefit of the best and first. But then after that, after number one and number two, we should also proliferate American technology standards, compete around the world, fuel this flywheel of funding our R&D so that we can continue to be the mightiest technology industry in the world, so that we can fund the mightiest military in the world. And all of that, I think, goes hand in hand.
Several times, Chairman Huang, you've talked about energy as being a pacing problem here. We, when we invented LED lighting, we just lost the demand signal, and half of our electricity grid is merchant supplier, and so they don't buy ahead of need. And so we're now really way behind. And you pointed out that China has built out twice the capacity of electricity than has the United States. how big a constraint do you see that as being for our build out for this revolution that you're trying to create?
Deeply serious. I think at this point, we have to use every form of energy we can. I believe we can't rely on the power grid. We got to build behind the meter. We obviously need power generation systems. There's no question we should try to encourage and try to accelerate nuclear. We need to have energy growth very, very shortly. In the meantime, we're advancing our technology so quickly. No company our scale has ever introduced new generations every year. And when I say we just ship a new chip every year, people, when people, because there's so many gamers in the world and they've known me for so long, and when they think about what NVIDIA builds, they think it's a module that looks like a gaming graphics card, our GeForce graphics card, and they plug it into their PC. Well, a GPU for AI centers, AI data centers, that GPU weighs 2 tons. It has 1.5 million parts. It consumes 200,000 watts. It costs $3 million. Every so often somebody says, these GPUs are being smuggled. I really would love to see it.
Yeah.
Not to mention, you have to smuggle enough of them to fill a football field full of these things so that you could run it as an AI data center. And so, anyhow, the technology that we make each year allows us to increase the performance at about the same power by many times. And let me just pick a number, say 5 times or 10 times each year. As a result, our energy efficiency improves by 5 times or 10 times each year. But the problem is this. We're at the beginning of this technology build-out. I'm improving the performance by a factor of 10 times each year, but demand is going up by a factor of 10,000, a million times each year. AI is getting more compute intensive, the adoption's going way up. I've got all these exponentials. And so we're going to keep chasing this. We're going to be completely dedicated to advancing the technology as fast as we can. But the bottom line is we need energy.
Yeah, and I forgive me for interjecting myself. I do think we have to overcome the NIMBY constraints. We're going to have to find some structure of federal preemption so that we can overcome the barriers. That's my comment. That's not your comment. I don't want you to get in trouble for my saying that. Let me ask you, last year...
Thank you for that.
Last year, the world installed 2 million robots. Half of them were in China, which is really astounding when you think about it. Tell me how robots fit in with AI.
Let me just give you one example of why it's around the corner. These days you could describe in text, and you give it to a video AI, and it generates a video. You guys know this, right? It actually, from words, you can generate a video, okay? And let's say the video is Jensen reaches over, picks up a cup. So I take a picture of this screenshot, give it to the AI. That's the starting condition. And I say, now cause Jensen to reach over and pick up the cup. The AI creates pixel by pixel, token by token, my arm picking up the cup. And that everybody knows is possible today. You guys have seen it. Well, the AI can't tell the difference between it manipulating pixels versus it's manipulating a bunch of motors. So the idea that I can tell the robot, pick up the cup, is clearly just around the corner. We just have to take that AI, which currently sits in the cloud, and we have to put it into, otherwise called embody it into a physical mechanical system, which is called robotics. So the AI is around the corner. We can see early evidence that the technology must be possible. Now, China is going to be very, very good at this for several reasons. They have great demand. They have a natural indigenous demand for more workers. Manufacturing is a core part of what they do. We, by the way, because we're now reindustrializing, reshoring, manufacturing, we now again also have significant demand for factory automation. And there's no question we have a shortage of labor. We have, right? We all know that our industries would be larger, more profitable, more vibrant if we just had more workers. And so they have the same challenge. They have worker shortage coming up, very severe worker shortage coming up. So they have a national strategic imperative to make sure that robotics happens, number one. Number two, they have the AI technology. And number three, this is where they have the big advantage. They're really very good at electronics and mechanical intersections, otherwise known as mechatronics. This entire area they have the harmony of demand and supply side capability. Now, many other countries, Japan has surely demand side. They have the mechatronics, but Japan needs to have much better AI technology. Germany, great demand, extraordinary mechatronics. They need to have great AI technology. United States, if we reshore reindustrialize our nation, we will have great demand. We have great software technology, but we really, at the moment, need to improve our mechanical electronics.
Yeah, I mean, using AI to find a better, vegan recipe for foie gras, maybe something my wife will look up. But we need to make this.
That would be a miracle indeed, sir.
It would be good. But we need to turn this into productive machinery. That's and right. The way in which it's going to change the landscape. Let me ask you, because we're running out of time. I was talking to a friend of mine who's a dean of a major research institute, and I asked him, I said, how is your faculty dealing with AI? And he said, well, the engineering faculty is excited. They really think this is fabulous. He said the science faculty is really curious, and they think it potentially opens up real opportunity. And the humanities faculty thinks it's the end of the world. So it is a shorthand for the anxiety that people feel about the dark side of AI. How do you talk to us about that?
Let me start from the end. There's no question that everyone's jobs, profession, will be affected by AI. Because the tasks within our jobs are going to be dramatically enhanced by AI.
Yeah.
Some jobs will become obsolete. New jobs are going to be created, and every job will be changed. So I used two words just now, and it's really important we think about these two words very differently. One is task, the other one is job. Now, it turns out, I think it was something like 7-8 years ago, a very important AI scientist, maybe the most important AI scientist, declared the first application for AI will be radiology, because computer vision was the first breakthrough. And that, in fact, entire radiology industry within 5 years will be completely transformed by AI. And that in 5 years' time, radiologists will all lose their job. And he advises that no one should be a radiologist. That was his advice, and it was taken very seriously. Now, some 5, 6, 7, 8 years later, every single radiology platform has been completely transformed by AI. 100%. Every single radiology platform. The number of radiologists has increased. The question is why? And the reason for that is because, as it turns out, studying the scans, studying the images, is the task of a radiologist. The goal or the job of a radiologist is to diagnose disease. This is true for many, many people. People say, I don't need software engineers because apparently coding is going to be automated. I've given AIs to every one of my software engineers and hardware engineers and engineers, period. 100% of NVIDIA has AI assistants, AI coders. And they're busier than ever. And so the question is, what is the task versus what is the job? No different than a financial analyst. The task is mess around with spreadsheets. But the job is to make a financial advice. The job is to help a customer. The job is to analyze the market, make a prediction about the market. And so there's still, the human factor is still quite significant. And I would just tell everyone, before you decide that that AI is something that you're worried about or scared about, go engage it, go use it. And even in the humanities, the fact of the matter is without, with AI today, my writing has improved. I don't think the quality is. It still writes in my taste and my ways, but my speed of writing has dramatically improved.
Yeah.
And so I'm more productive today. I'm still writing the original pieces. I still have to write the original voice. I still have to create the original thought. Still has, but every so often, as you know, when we derive other speeches out of other previous speeches, the concepts are very similar, but the content, the delivery, the context is so different. We now can use AI to help us regenerate the first draft. So for me, for the humanities, I would just say original thought, original writing, your taste, made with human hands, are still always going to be valuable.
I went in for an MRI recently. My wife said, make sure you take a picture. I don't think there's a brain up there, but I'd like to see it if you could prove there's something.
And what did you find out, sir?
There was nothing. I mean, she was right and I was wrong. We're coming to the end, and you're in Washington. You don't. This isn't always a joyful experience to come to Washington, but share with us what your thoughts on how we should think about this remarkable revolution that's appearing in your world. You're leading it. We're going to experience it. We're probably going to try to regulate it. We don't know how to do that. Tell us just a little bit how you think we should be anticipating this and thinking about our future.
There are many, of course, that we spoke about many different things that Washington has been extraordinarily helpful in already shaping the outcome for our nation. We spoke about industrial policies and how, in fact, a heavy-handed approach was necessary, and it was just in time. It is the case that Washington, D.C. is foreign to me, and I've had the benefit of coming here now since the first time I saw you, our first night, and it's unnatural to me. However, what I can tell you is we all want the same thing. We want America to win. We want America to be the greatest nation in the world. Mm-hmm. We have extraordinary capabilities. It's hard not to be romantic about this country. My parents had the American dream. My father always wanted us to grow up in the United States. He sent us here when I was 9, and they had almost nothing to start a life here, and somehow through that journey,
it worked out pretty good.
I'm here with the privilege of leading one of the most consequential companies in the history of humanity.
Yeah.
And you just can't write a better story than that.
Yeah.
You can't not be romantic about this country. I'm surrounded by extraordinary scientists. I'm surrounded by extraordinary people. All of our technology partners, the ecosystem that we have here. It is, I don't want to be complacent, but it is a miracle. There's no question about it. And I had the benefit of working with every nation in the world. And so I think we can say for certain that we want the same. We want the same outcome for this nation. It is important, however, that I come here so that I could at least explain what is AI. It's 5 layers. I can explain what is impact, how is it going to evolve, and how certain policies, although on appearance might achieve whatever objectives, that the long-term consequences, the unintended consequences, could be quite dire for the United States. And so I have the benefit of at least explaining it from the perspective of technology, and help advocate for technology leadership so that we could secure our national security. And so I have that benefit, and I'm deeply grateful that the people I get to meet here in Washington, D.C. has always had an open door. And although this is new for me and I'm clumsy at it, I can also say that I'm very grateful that Washington has been very open to me.
I know the answer to this question, but I still want to ask it. Are you optimistic about the future?
Oh, absolutely. 1,000%. 1,000%. The best of days are ahead of us. I don't have to work. I think I've done,
I think that's true.
and Ambassador Rudd, when he first met me, all my hair was black, and now if you were to take an image of my brain, it could turn out to be the same color as yours, and so, but nonetheless, this is the one decade I will not miss.
Yeah.
I simply won't miss this decade. I don't want to miss this next 2 decades. We are going to do more for the advancement of science. We're going to do more for the advancement of industry. We are going to do more for this nation in the next 2 decades than potentially all of it combined in the past.
Yeah.
And so I don't want to miss that. This is the best of times.
I totally share. I think this is going to be the most marvelous period in humanity, and we're looking forward to it. Would you all say thank you with your applause?